In this project, we aimed to improve the realism of previous groups' water simulations by adding whitewater effects. We first implemented position-based fluids to simulate the movement of the water. Then we added diffuse particles based on the positions and velocities of the fluid particles. Finally, we implemented marching cubes to generate meshes to be rendered in Blender. The code structure of our project was modeled after Project 4. We built particle and diffuse particle classes with positions and velocities, and implemented different papers to simulate effects such as incompressibility, viscosity, and diffuse particle generation. We also implemented a different collision response than in Project 4, which reflects velocities when colliding with an object. For mesh creation, we implemented the marching cubes algorithm, which subdivides our environment into small boxes and decides if it should render a triangle at each box edge depending on the value returned by the ISO function. For each frame, we convert the triangle meshes into an OBJ file. To render each frame into a video, we use a Blender add-on called Stop Motion OBJ. In Blender, we added the glass BSDF material to make the fluid look more like water. We also rendered the diffuse particles together with the fluid by importing .ply files and converting them into a mesh. Tuning parameters makes a massive difference in the final result, and a correct implementation with bad parameters simply will not look good. Even though we automated part of the tuning process, because there were so many parameters, this part of the project took a lot more time than any of us expected, though it was a very valuable learning experience. Future students should definitely pursue a similar project because there is plenty of room for improvement. In terms of efficiency, our marching cubes algorithm is not the fastest, which bottlenecked our pipeline. There are also other ways to represent fluid-air interaction that might be able to produce better results than our implementation.